welcome back, everybody. I hope you've had a good day so far and gained a lot of new insights. Did you have a good day so far? Yes, perfect. Did you have a good day so far? Did you learn something new? Perfect. As we're entering the next input, I'm happy to announce that everything we present to you on this main stage from now on is curated by Ji-Hoon Kim, known as a columnist from Das Filter and Hybrid Music Lab. So what is the Hybrid Music Lab? It's part of the Berlin Music Commission, and it looks at current digital developments at the intersection of music and technology. The aim is to sustainably network pioneers, movers and shakers and visionaries from both disciplines, so technology and music, and to encourage them to work together on joint projects. And we're super happy to see Ji-Hoon Kim's curation on the main stage this year. As for the next input, it will be given by Dr. Simón Sun. He will be our first speaker from the series, and scientist by day, producer by night, Simón will talk to us about the relationship between art and science. Are there similarities in the process of creation? I'm excited to hear the answer, and at the end of this talk, you will also have the possibility to ask a few questions if you like. For now, welcome Dr. Simón Sun.
Hello, everyone. Thank you for coming to my presentation as part of the Hybrid Music Lab. And my presentation is titled Signal Transformation, Science as Music Material. And it is my attempt to integrate the creative arts and with scientific exploration to find new ways of creating music. So, as a quick brief outline of what I will be talking about today, I will first start out talking a little bit about who I am and how this relates to what it is that I am doing here. I will then talk about some of the broad ideas and themes that underlie this approach to music and how I've specifically applied it to my own materials, and then perhaps discuss a little bit about how to broaden the scope of these kinds of ideas. And then finally, I will briefly touch on why creating music this way could be important. So a little bit about myself. My name is Simón Sun, and I label myself a scientist, artist, and activist. I am trained in neuroscience, genetics, and endocrinology, typically. As was said by our wonderful moderator, my day job is a postdoctoral researcher researching hormones and how they affect neurons and genes in the brain. I am also part of the new Center for Applied Transgender Studies, which is a broad post-disciplinary network of scholars that advocates for an approach to trans and gender studies that mirrors the creative approach that I've taken with my music. I am a classically trained pianist and composer, and I'm also a graphic artist who has been able to take scientific discoveries and create works that illustrate these discoveries. And so I'm kind of this big disciplinary milieu of all these things mashed together. And so as a part of that, I have tried to find a way to express scientific discoveries and ideas into a form of music. But before we get to that, this is not a completely new idea, right? There are many examples of art installations and projects that have been described as an interdisciplinary attempt to merge science and music. However, these approaches typically are structured in a way where you have half of one thing, like the art, and then you have half of the other in the science, and then supposedly if you add them together, you get a whole new thing. The problem with this is that very often this type of approach ignores the methodologies and theories that are pertinent in either the artistic form or in the scientific exploration form, and usually they end up as fancy data visualizations, sonification, examples like just putting a bunch of microscopes in an art studio, or projecting pictures of neurons on the wall, or looking at data in VR. In my opinion, this is pretty much something that is like superficial and uncreative and more of a little gimmick to get people engaged in the work. And so what I propose is that taking a more post-disciplinary approach can actually overcome many of these barriers when it comes to trying to unify these aspects to create something new. And so a post-disciplinary approach is a dissolution of the methodological and theoretical boundaries that are established by the way we typically think about these academic disciplines. And so that essentially boils down to using the methods from one discipline and applying it specifically into the other discipline that, that hasn't typically been done, with an awareness that the new context for that methodology can lead to something new and unpredicted. So in less jargony words, think as a science, do as an artist. The idea being is that you use the data itself as the raw material and then creating it in a way that can be experienced as an art form. Of course, there are limitations in both either medium or either process. For example, the rhythm that we expect in music is very not often present in any form of experimental data or natural phenomena, and so that's one of the limitations that needs to be overcome. But thinking about the solutions and applying them, it becomes part of the form. And one aspect that is pretty important about making sure that this process is at all feasible is establishing your creative constraints, rules, and the framework in which you are applying or working in and applying the musical form. So, moving on. So, how is it that I've actually engaged in this process? And so there are 3 stages that can broadly be thought of. You have your experimental phase, an analytical phase, and then a creative phase. And so in the experimental phase, what we are doing is looking for or understanding what it is that the experiment or the scientific discovery is attempting to understand. And so my example, I record from neurons, and you get these little spikes of synapses of neurons communicating with each other and communicating with each other. And then you take this data, you analyze the material in the data, and you translate certain properties into something that can be grasped, handled, manipulated, understood as to which aspects of the data are important or matter to the art, or in this case, the music that you are trying to create. And then finally, you get to and so at this stage, you have a very rudimentary application of certain parameters. In this case, I'm taking the size of an event from the neuron and translating it to some kind of note. And then from this sort of basic procedure, you get the building blocks and the actual material that you can use to create some kind of work from. And it's using this material that allows you to make a story or a narrative or some kind of compelling emotional thing that originates from the material that you had used itself. All right. So just to briefly describe what was the actual experiment that I did, give us a little sense of how we can move through this kind of process in creating music. And so the experiment that I was conducting was I was recording from a neuron to listen to its synapses, its different connection strengths that it possesses, To do this, you grow a bunch of neurons on a glass surface. You take a glass pipette that you make that's a microscopic glass pipette. You go up to one of the neurons, you attach the pipette to the membrane, and then you break into the cell. And then what you get from that are these natural electrical currents that represent the synaptic strengths, or how strongly connected a neuron is to the thousands of other neurons that it happens to be talking with. And then from that, I have been using that to study synaptic plasticity as a scientist, trying to understand how changes in neuronal activity can change synaptic connections, which is somehow related to learning and memory, but we're still trying to figure that out. But moving on from that, now that you have your raw data, the question is, what is it that is important about the data itself? What's the signal? Which parts are important? Which aspects can we use to parameterize and translate into a musical language? And this is guided by the experimental design itself, so the science itself, and the data, the type of data that you are acquiring. And finally, so from this process of analyzing or looking at the data, you find what matters in the experiment and then apply that sort of similar idea to another context, which is in this case, making the music. And so from a scientific standpoint, what's important about this data are each of these little ticks and how large it is, or how fast it changes. And so these important aspects that are important in the scientific discovery, we can use that as the parameterization for the music itself. And so in this case, the occurrence of one of those events at any given time can establish when it is that we would hear a sound. The amplitude of the event, or the size, determines which note in a particular scale that is played, and the decay, or how long the event lasts and how long it takes to return to some baseline, can tell us how long that note should be. And then I've written a custom computer program that takes this basic process and applies it to all of the data that I've acquired, and gives me a set of MIDI sequences that I can use to create some kind of music from. So just as an example, this is essentially what ends up happening. And as we continue to, quote, analyze the data, we can apply operations that are used in the scientific analysis of the data and find some kind of musical parallel. So we can take this trace that generated that melody and do things like transpose it a little bit so that we get some harmony. We can invert it so that we have the line going in a different direction, or the musical line going in a different direction, and then adding several lines of that same data. So this is where most science-inspired art typically ends, right? You've taken your data analysis, and then you've created a nice-sounding thing that comes from the original data itself. But I think that you can move forward. We can create something from this material itself. So that comes into the next stage where we take this material and we do all the things that we do in the music creation medium. You can use it, you can sample, you decide what kind of instrumentation, the articulations that you use, whether or not some component is the melody or the harmony. The structure of the song can come from either can come from the way that the data has emerged, or you can creatively apply your own song structure to make some kind of point. And so this whole process is very much like the actual music composition. And so I'm going to go through another example just to sort of demonstrate how this process can occur. And so all of this next song, all of the components come from a single trace that was recorded from a neuron that was treated with a particular drug. Details don't matter, but this drug was the experiment, and it made the neuron do something different. So there you have a drum track. You've taken one part of the data and you've created a drum track by just forcing or imposing the structure of a chromatic scale onto the amplitude of the events. So the next is, well, can we make a bass line? So I take the same data and I put it into a pentatonic scale. That's all well and good, but that still sounds like a whole bunch of chaos, right? It's just a bunch of random events. And that is because we've only imposed a certain amount of parameters of structure to it. And so the next thing I did was to create some kind of threshold where only specific events were considered to make up the melody. The nerdy part of this being that looking at a particular, how fast a particular event occurred, and that if it crossed that threshold, representing some sort of property of the neurotransmitter receptor that was occurring in the neuron. But what we get here in the music is what sounds like a nice melody. And so you have all your parts. What do? You put it together. Thanks. I think it's pretty cool. So this kind of process doesn't have to be limited to the kind of data that I've acquired. There are plenty of different kinds of sciences, but all you really need in the end is a signal that changes, which is exactly what data is some kind of change in a signal that we're looking at in order to better understand some property of some natural phenomenon. So just to give a bunch of examples, like the ones that I've been using, neural electrophysiology that measures the electrical properties of neurons. You could do things like looking at hormone fluctuations or pulses or waves within the blood serum. You can take behavioral data where you've unbiasedly tracked the behavior of certain animals, and then whether or not an animal is in a particular behavioral state could be translated to some kind of harmony. Another idea is looking at population changes, migration patterns, even things like changes that occur in social media networks, and also looking at the thermodynamic fluctuations as temperature changes either on a short-term weather scale or a long-term climate scale. But these things don't have to be limited to signals that change in time. You can also just, whatever variable it is that you're looking at that changes, such as in chemical spectrography, you are looking at different masses and then analyzing which masses occur the most to determine the chemical structure of a molecule. And so something like that could be translated very similarly. And then lastly, one project I'm currently working on is looking at the genomic structure. So the genome actually doesn't exist as DNA just stretched out. It's actually much compact, and it has its own three-dimensional structure, and that three-dimensional structure can be accessed and analyzed, and that within that structure, with those differences, you could translate or use some similar process to generate some kind of music material. So finally, cool, but why do this? Besides, good music, science, and vibes, it forces creative thinking, this sort of post-disciplinary approach where you're forcing yourself to think as a scientist or think as an artist can generate new ideas that typically would not have occurred if such a process was not engaged in. I think it can enhance the communicative power of both the science and the music. It can be used for things like illustrating or describing public health patterns that exist. So for example, in the recent pandemic, different waves or different transmission patterns, climate change, data is filled with this kind of change and parameterization that you can engage in. And a little bit more broadly, it's a way of expressing the grandeur of the natural world made accessible to other people who aren't typically, buried in all of the science. And so, on a broad sense, it encourages an active dialogue between artists and scientists that I think can lead to work that has a material, that uses materials from a natural exploration to create something that is beyond just the impact of either the data or the music by its own. And so with that, I thank you for your time.
Very much for this presentation. I am super impressed. I guess most of you are too. I love the music, and I wonder for people who cannot do all of this, since you are a multi-talent, what kind of inspiration can we as creatives or we as upcoming artists take from that? Is there any tip, any thing from the scientific work you do that we can take into the creative art that we do?
Right, and that's a great question. This is where I get at this idea of creating this kind of dialogue, this space for scientists and artists to talk to each other, right? And as an artist, typically when people think about science-inspired art, it's oh, galaxies are cool, right? Look at this pretty picture, and then someone draws some kind of illustration. But going beyond just thinking about, oh, the niceness of that picture. As a creative, you can talk with the scientist to better understand what each of the parts of a particular signal is. And from that understanding, ask questions of like, well, can I translate this into a particular scale? Can I use it to define instrumentation? And that back and forth, I think, can, allows for the creative people to engage in something like this.
Cool. Is there any question from you that you have that we want to discuss? If not, great. We'll have a quick changeover. Thank you so much for your presentation. After that, we're going to talk about AI, about meditation, and so much more. See you in 5. Thank you.